Hello and welcome to Lesson 5 in my series of videos explaining A-level calculus. This video is focusing on a part of differentiation that I haven't fully covered in a video yet, but this section is quite small and so it shouldn't take too long to go through. Make sure to check the description of this video to note down any errors I found after making the video, and check the answers on the screen now to last video's questions. If you got them right, well done. But if not, try again or ask me in the comments and I'll do my best to explain it. So today, as you can see on the screen, we're looking at whether or not a function is increasing or decreasing. So a function is increasing when the y value increases as the x value increases. So if we look at the example on the left, this one is increasing because as x increases, y is also increasing for each of these three lines. They're all increasing functions. And a function is decreasing when the y value decreases as the x value increases. So as you can see on here, as we go along the x-axis, the y value is getting smaller for every single line here. They all are decreasing functions. But some functions, some equations, some graphs aren't always just increasing or decreasing for all sections. Some graphs have sections of increase and sections of decrease. So if we look on this graph here, for example, the bits in yellow are where it's increasing, so the y value is getting larger as we go along the x-axis, but the green bits are where it is decreasing, as it's going, the y value is decreasing as we increase the x value. So we're going to use differentiation and calculus, the things that we've learned in the previous videos, to find the sections that are increasing and decreasing. So technically, a graph is increasing when the rate of change is positive, or the derivative is greater than 0, and a graph is decreasing when the rate of change is less than 0, or the derivative is negative. So we can use our derivative to find the parts of the graph when it is increasing or decreasing. So let's take an example here. This question says, find the interval where the function y equals 2x cubed minus 3x squared minus 36x plus 5 is increasing, and the interval where the function is decreasing. So as I said earlier, we need to use the derivative. So first we differentiate to find dy by dx, which in this case is 6x squared minus 6x minus 36. To find the interval when this increases, we want to find when the derivative is greater than 0. So we can write 6x squared minus 6x minus 36 is greater than 0. We can then cancel all the 6's to get x squared minus x minus 6 is greater than 0, which can then be factorised to get x minus 3 multiplied by x plus 2 is greater than 0. Now, we need to find the interval when this statement here is true. So if we draw a little sketch of this graph here, x squared minus x minus 6, that will help us to find the interval when this is true. So first, to draw this sketch, we want to find the roots of the equation, so where it crosses the x-axis. And in this case, we can find it by setting this equal to 0, and then we know that this is going to be equal to 0 or crossing the x-axis when x is equal to 3 or x is equal to minus 2. And because the graph is a squared, it is a quadratic, with a positive coefficient, we know it's going to have this kind of U shape, and it's going to cross the x-axis at minus 2 and 3. So we want to find when this statement is true. Where is this graph greater than 0 or above the x-axis? And looking at our sketch, we know that this is true when x is less than 2, so the two yellow bits here, and when x is greater than 3. So we can say that the function is increasing when x is less than minus 2 or x is greater than 3. Now that's the first bit of the question done. Now we need to find the interval where it's decreasing. So when it's decreasing, we can say the opposite is true, so it's less than 0, less than 0, less than 0, And again, if we look at our sketch, we can see that this will be below the x-axis or less than 0 when x is between -2 and 3. So we can write that it is decreasing when x is between -2 and 3. And that is our final answer. So quite an easy lesson, this one, hopefully. I just thought it would be important to make a small video on it since I haven't covered it before, and it was a good time to do it before moving on to integration, which is the different section of calculus to differentiation, and I'll be covering that in the next video. On screen now are some more questions on this lesson, as always, the answers of which will be at the start of the next video. Give me your feedback in the comments, let me know what was useful and what was not useful. Note down any errors I made in the video in the comments for me, and I'll add them in the description for people to see. So quite a short video this one, but hopefully it all made sense. Thank you for watching, subscribe to be notified on more videos, and see you in the next video.